room temperature again. And in the last class we discussed about conduction, how conduction takes place, and the different processes involved with it, the different practical applications related to conduction. And the next one we'll be talking about today is convection. So what is convection? Convection is the transfer of heat. Okay, the transfer of heat when the particles move from one place to another. And I think I gave you an example last time how convection is related. So what happens during convection? During convection, the particles which get heated, they start rising up. And when they start rising up, the cold particles which are above, they will come down. The cold particles, they come down, and the hot particles, they rise up. So a current flows. Okay, a series of current flows. So this is how convection takes place. And I gave an example last time, the example of a teacher and the student. So how would a teacher, if the teacher just sits in her place and then asks the students to come and get the answer script or their copies, what do you have to do? Each one of you have to come individually, collect the copy and then go back to your respective place. This is exactly how the molecules or the particles move. When the particles get heated, they start moving up, and then the cold particles which are above, they will come down to take their places. So this is how the convection takes place, and convection is possible in liquids and gases. Convection is not possible in solids because in solids, particles are not free to move. The particles are very tightly packed, so they don't have enough space to move around, okay, to move freely around. So they can only simply vibrate in their own place. Whereas convection, particles have to move from one place to another. They change their place. So convection is not possible in solids. Convection is, however, possible in liquids and gases. So you can say convection is possible in fluids. So you can see here, heat transfer due to current in a fluid. Warm fluid actually moves, changes position. Warmer areas expand, are less dense and rise. Convection current create wind, weather patterns and sea bridges. So these are the practical application, the effects of convection currents. They can create wind, they create weather patterns and sea bridges and many more. Now, this is for conduction. Now, this is how convection takes place. What happens is, say you are boiling water. Okay, you have placed a vessel in which you have filled it with water. Now, the particles which are here, which are closer to the heat, they start getting heat. They started heating up. Okay, they get heated, and then they start rising up. When they rise up, the cold particles which are already here, the cold particles of the liquid which are not heated, which are away from the heat, they start coming down. The hot particles, they rise up, and the cold particles, they come down. So this is how what happens. So the hot particles rise up and the particles will be here. The cold particles, they come down. They get heated, again they rise up, and the cold particles which are here, they will come down. And then they continue until all the water starts boiling. So when all the water starts boiling, what does it mean? It means all the particles have heated. All the particles have gained heat. Okay. You must have seen how water gets boiled or a liquid gets boiled, isn't it? They start from the bottom, not from the top, right? Because the water particles which are closer to the heat, they get heated first and then they rise up. The cold particles, they come down. They get heated, again rise up. Another set of cold particles, they come down, they get heated, they rise up, and then the process continues till all the particles get heated. And this phenomenon, this process in which heat is transferred is called convection. So see, this is how what happens. The red one here indicates that the hot particles are rising up, and the cold particles are represented by the blue lines. Okay, the hot particles are represented by the red ones. So the red ones represent warm molecules and the blue one represents cool molecules. So these are how the fluids are heated. Even the gases are heated in the same way. Now, the most important phenomenon of convection is land bridge and sea bridge, which I'm sure you have learned in geography already, but just a revision here. So what happens during land bridge and sea bridge? Okay, sea bridge takes place during the daytime. As you know, when we compare land and sea, which gets heated faster? Obviously the land. The land gets heated faster compared to the sea because water has very high specific heat. Okay, water requires a lot of temperature to get heated, and it also takes a lot of time to cool down. So land gets heated faster than water. So when land gets heated, the particles which are closer to this land, okay, the air particles which are closer to the land, they start rising up. Okay, when they start rising up, see, they are rising up. The red one represents the warm air, they are rising up. Now when they rise up, what happens is here, it becomes kind of empty. Okay, so in order to fill this vacuum, the cool air from the sea, they rushes towards the land. The cool air from the sea, they rush towards the land, they move towards the land and fill the space. Again, the cool particles of the sea, they get heated and then they rise up. Again, another set of cool particles from the sea, they come to the land. So this is how sea bridge takes place. So what is sea bridge? Sea bridge is when the cool air blows from ocean or the sea to land during the daytime. That is your sea bridge. Okay, your land bridge takes in the evening. When we compare land and sea, which one gets cooler faster? Obviously the land. Land gets heated faster, land gets cooled faster. As I told you, water has a high specific heat. It takes a lot of time to get heated up and it takes a lot of time to cool down compared to land. So what happens during the night is the land would be cooler compared to sea. Okay, the water. So the water will still be warm here. When the water is still warm, the particles which are closer to the water, that is the air which are closer to the water, they start rising, they get heated and they start rising up. And when they start rising up, here a vacuum is created. And when in order to fill this vacuum, which air rushes in? The cool air from the land. Okay, the cool air from the land goes and fills the space. They get heated, they rise up. Another set of cool particles from the land go above the sea. So this is your land bridge. When the cool air blows from land to sea during the night, that is called land bridge. And when the cool air blows from sea to the land during the day, that is called sea bridge. So this is one of the phenomena of convection, one of the effects of convection. Okay, so this is exactly how convection takes place. The warm particles rises up, the cool particles comes down to fill their space. They get heated, they rise up, again another set. So it continues. Okay, now the difference between conduction, convection and radiation. The process of heat transfer along a body from one molecule to another without actual motion of molecules. So as I told you already that the particles, they do not actually move. They simply vibrate in their own place. They don't move from one place to another. They only vibrate. That is your conduction. And conduction is possible in solids, liquids and gases. And it's mostly common in solids because the particles are tightly packed, thus the heat can be transferred easily in solids. Convection. In convection, hot particles rises up, cool particles come down. So a set of series of current is formed, which is your convection. And convection is possible only in liquids and gases, which means they are possible only in fluids because in solids particles are not free to move. Radiation, however, does not depend on any state of matter or it doesn't require any medium. It doesn't require air, water, any medium, land. It doesn't require any medium at all. Okay, the particle just gets transferred by electromagnetic waves. So, here an example over here is given, and that example is microwave. Now we all know how microwave operates, isn't it? You just put food inside the microwave, turn on the timer, and then you start it. And then after the certain time, after you stop it and when you open it, the food is warm, isn't it? Now with the supply heat, there is a heat around it, and then how does the heat transfers? It is through radiation. Okay, so radiation does not depend on any material. Now, we'll discuss more about radiation when we are discussing radiation. First, we'll discuss all the effects of convection. Okay, that means the practical uses of convection currents. Okay, we had this for radiation. So for convection, I'll be discussing the most important, that is sea bridge and land bridge, how it is created, how it occurs, the sea bridge and land bridge. Now we'll be discussing about radiation. As I said, in radiation you don't require any heat. Let me give you an example. The example would be the same. The teacher comes to the classroom, has the answer script, and instead of going place to place, or instead of calling you to her place, what she prefers is she throws the copy. She just passes it. She throws the copy, or she throws the answer scripts to your respective places. In that case, you all get your answer scripts, you all get your copies, but did you actually have to move? No. The particle didn't have to move. Did the teacher have to move? No. The source doesn't have to come closer to the object or the particle, isn't it? So, this is how exactly the heat is transferred. That means the particles and the object, the source, doesn't have to be in contact. Okay, they don't have to come closer. For example, the ray of the sun. You don't go to the sun, or the sun doesn't come to us, isn't it? It's fixed in its own place. The earth is revolving in its own space, isn't it? Neither the earth nor the sun, they move around from their place to come closer. But still we can feel the ray of the sun, we can feel its heat, isn't it? It is because of the process called radiation. So radiation is a process in which the source and the object, they don't have to be in contact. Okay? It can just be transferred through electromagnetic waves. So it doesn't require any medium. Now some of the application of radiation is, those black, the color black is a good absorber of heat, whereas light colored or white, they are good reflectors of heat. Okay, they are good reflectors of heat means when a ray of light comes and hits that, when a ray of light comes and touches that white or light color, it will reflect back, it will go back. Okay, so white and light colors are good reflectors, whereas black or dark colors are good absorbers, they absorb it. And that is one reason why the utensils at home, which we use at home, they are painted black at the bottom. Nowadays, most of the utensils, they are painted black or painted dark colored at the bottom. The reason is because black or dark colored are good absorbers of heat. They absorb heat more. Okay, as you know, metals are good conductors, they will be absorbing heat. On top of that, if they are painted black, the heat absorbed will be more, and the food which is inside the utensils will be cooked faster in a shorter time. Okay, thus the cooking utensils are all painted black, so that the maximum heat can be absorbed into the food that are cooked in this utensils. Usually the cooking utensils are made of metal, as we have discussed this. So metal, as it is, it's already a good absorber of heat. On top of that, when it's painted black, more heat will be absorbed. The food will be cooked more properly and more in a shorter time. Another one is we wear white clothes during summer, in a bright sunny day as of now, right now, it's very bright, and most of us, we prefer to wear light colored clothes or white clothes, isn't it? Why? As I told you, white or light colored clothes, they are good reflectors of heat. That means when a ray of light touches them, it reflects back. They don't penetrate in the body. Okay, that's why they reflect back. You must have seen houses, buildings or houses on a very, hot places. They prefer to keep it light colored or prefer to keep it white, so that the heat is not absorbed inside the house and the house remains cool comparatively. Okay, it will not be that hot. If they paint it with black, what will happen? It will be the buildings, the color will absorb the heat and the house will become more hotter. So in order to avoid that, they prefer light colored or white color outside the houses. And during winter, we prefer dark colored clothes or black clothes because they are good absorbers of heat and they keep our body warm. When they absorb heat, our body becomes warm. Okay, that's why we prefer dark colored clothes or black clothes during the winter and white colored clothes or light colored clothes during the summer, because white are good reflectors and black are good absorbers. Okay, another one is room heaters are polished reflectors. You've seen those room heaters, they have the silver surface inside, isn't it? If you have noticed or not, they always have that silver surface inside. Either it's mostly it's silver. Why do they have silver? Is because silver is a good reflector of heat. Now that silver color, the light color, will reflect the heat, and thus the heat will be transmitted to the room. It will not absorb the heat, but it will reflect back. So when it reflects back, it comes to the room. That means the air particles which are closer to the room will get heated faster, and thus the room will become warmer. Now see here, have polished reflectors because bright polished reflectors reflect heat more efficiently and hence more heat is generated in front of the heater. At the same time, since they reflect heat, the appliance or the unit is saved from getting heated or catching fire. That is an advantage. So this is what I meant. So this heater, this one, the inner part, I'm talking about this inner part. Okay, the inner part, they are usually polished and light color because they reflect heat. They are polished so that they reflect heat. The more the heat is reflected, the more warmer the room will be, and also the electricity consumed will be less. So they, in a way, they save power also. Now this is your car radiator. You must have heard about the car radiators, isn't it? It's generally black in color because so that they absorb heat, and from here once it gets heated, when they get heated, what happens? The heat will start off the engine. When the engine gets heated, then only the car starts, isn't it? Unless until the engine heats up, the car will not start. So in order to warm the engine, the radiators are black in color so that they can absorb heat. So this is all we have. So the different effects of conduction, convection and radiation. In the next class, we will discuss about thermostat, how it works and how it operates. Okay. So after that, I think we'll be completing the chapter and I'll be giving you some assignment in the next class. Thank you and have a good day.